Welcome to another episode of the Understanding Crypto series by Thomas Plunkett. Today we're going to look at the ERC20 token standard for producing tokens on Ethereum. Just a reminder, these slides and this video are available under the Creative Commons license, and I'd like to thank Andreas and Gavin for making their content available under this license under the Mastering Ethereum GitHub site. So let's talk about tokens on Ethereum. Blockchain tokens existed before Ethereum. In some ways, the very first blockchain currency, Bitcoin, is the token itself. Many token platforms have been developed on Bitcoin and other cryptocurrencies before Ethereum came around. However, the introduction of the first token standard on Ethereum led to a veritable explosion of tokens. The creator of Ethereum, Vitalik Buterin, suggested that tokens are one of the most obvious and useful applications of a generalized programmable blockchain like Ethereum. In fact, in the first year of Ethereum, it was common to see Vitalik and others wearing t-shirts emblazoned with the Ethereum logo and a sample smart contract on the back of the t-shirt. There were several variations of this t-shirt, but one of the most common versions of this t-shirt showed the implementation of a token. Before we dive into the details of creating tokens on Ethereum, it's important to have an overview of how tokens work on Ethereum. Tokens are different from Ether because the Ethereum protocol doesn't know anything about the tokens. Sending Ether is an intrinsic action of the Ethereum platform built into the protocol, but sending or owning tokens is not. The Ether balance of Ethereum accounts is handled at the protocol level, whereas the token balance of Ethereum accounts is handled at the smart contract level. In order to create a new token on Ethereum, you must create a new smart contract. Once deployed, the smart contract handles everything, including ownership, transfers, and access rights. You can write your smart contract to perform all the necessary actions any way you want, but it is wisest to follow an existing standard. We're going to look at these standards. We'll talk about the pros and cons of the standards. And we're going to start with diving into the ERC20 token standard. And I will talk about other token standards in future lectures. So let's talk about the ERC20 token standard. The first standard for tokens, which is the ERC20 standard, was introduced in November 2015 as an Ethereum request for comments, or ERC. It was automatically assigned GitHub issue number 20, giving rise to the name ERC20 token. The vast majority of Ethereum tokens are based on the ERC20 standard. The ERC20 request for comments eventually became Ethereum Improvement Proposal 20, or EIP 20, but it's mostly still referred to by the original name ERC20. ERC20 is a standard for fungible tokens, meaning that different units of an ERC20 token are interchangeable and have no unique properties. The ERC20 standard defines a common interface for contracts that implement a token such that any compatible token can be accessed and used in the same way. The interface includes a number of functions that must be present in every implementation of the standard, as well as some optional functions and attributes that can be added by developers. So here's a look at ERC20 required functions and events. So an ERC20 compliant token contract must provide at least the following functions and events. It has to have a total supply, which will return the total units of this token that currently exist. ERC20 tokens can have a fixed supply or a variable supply. So in a fixed supply, for example, Bitcoin has 21 million units that are maximum that can be created. So you can have something like that, or you could have a variable supply. Ether, in fact, is a variable supply, and we can constantly create additional Ether. Balance of, we'll given an address, we'll return the token balance of that address. So you can send in your address and you can find out how many tokens you have as your balance. Transfer, given an address and an amount, we're going to transfer that amount of tokens to the address from the balance of the address that executed the transfer. So this is how I would give someone else my tokens. Transfer from, given a sender or recipient an amount, transfer tokens from one account to another. And this can be used in combination with approve. Approve, given a recipient address and an amount, authorizes that address to execute several transfers up to that amount from the account that issued the approval. So approve and transfer from work together. Allowance, given an owner address and a spender address, returns the remaining amount that the spender is approved to withdraw from the owner. Transfer, event triggered upon a successful transfer, called a transfer or transferFrom. So this will basically be a transfer event, and then an approval event, which is logged upon a successful call to approve. There are also some ERC20 optional functions. Name will return the human readable name. For example, if you've got a token representing the US dollar, it would return US dollar. Symbol returns a human readable symbol for that token. So again, if you have a token representing a US dollar, you might have it come back with USD. And then decimals return the number of decimals used to divide token amounts. For example, if decimals is 2, then the token amount can be divided by 100 to get its user representation. So here is what the ERC20 interface specification looks like in Solidity. So we've got a contract ERC20, which is, and then we've got a series of functions in those two events. The total supply, balance of, transfer, transfer from, approve, and allowance, and then the two events, the events transfer and approval. And then, obviously, besides the functions, you can also see the arguments that are being passed in the return types. Pretty straightforward. Let's take a look at how it works. If you examine any ERC20 data implementation, you'll see that it's going to contain two data structures, one to track balances and one to track allowances. And in Solidity, these things are implemented with mappings. So our first data mapping implements an internal table of token balances by owner. This allows the token contract to keep track of who owns the tokens. Each transfer is a deduction from one balance in addition to another balance. So we see here mapping, address, unsigned integer 256, and then balances. So again, this unsigned integer 256 can store someone's address. Well, actually, this is going to store the amount, and then the address is what we're going to be storing there. And so, for example, this balances mapping will keep track of every address that owns some number of tokens. And this unsigned integer will be the number of tokens that are associated with that particular address. Our second data structure is a data mapping of allowances. So with ERC20 tokens, an owner of a token can delegate authority to a spender, allowing them to spend a specific amount from the owner's balance and allowance. The ERC20 contract keeps track of the allowances with a two-dimensional mapping, with the primary key being the address of the token owner, mapping to a spender address and an allowance amount. So here, we've got our mapping with the address, and here you have the amount that, notice this is a two-step mapping. You've got a mapping of an address, and then that's mapped to another address, which is mapped to an unsigned integer. So the way this works is the first address is going to be the token owner. The second address is going to be the spender address, and then the allowance amount is this unsigned integer here. Up here, we just had a one-dimensional mapping. Here we have a two-dimensional mapping. Okay, so that's our ERC20 data structures. Now let's take a look at how ERC20 works from a workflow perspective. The ERC20 token standard has two transfer functions, that transfer and that approve and transfer from. You might have been wondering why. So let's dive into what's going on there. So ERC20 allows for two different workflows. The first is a single transaction, straightforward workflow using the transfer function. This workflow is the one used by wallets to send token to other wallets. The vast majority of token transactions happen with the transfer wallet, with the transfer workflow. Executing the transfer is very simple. If Alice wants to send 10 tokens to Bob, her wallet sends a transaction to the token contract's address, calling the transfer function with Bob's address in 10 as an argument for how many tokens to send to Bob. The token contract will adjust Ellis's balance by reducing it by 10 and add 10 to Bob's balance and issues a transfer event. Our second workflow is a 2-transaction workflow that uses the approve followed by the transfer from. This workflow allows a token owner to delegate their control to another address. It's most often used to delegate control to a contract for distribution of tokens, but it can also be used by exchanges. For example, if a company is selling tokens for an initial coin offering, they can approve a crowd sale contract address to distribute a certain amount of tokens. The crowd sale contract can then transfer from the token contract owner's balance to each buyer of the token, as illustrated in a diagram that I'll show you in just a minute. So here's our diagram. Here's the 2-step workflow of the ERC20 tokens. And you can see here for the approve and transfer from workflow, we're going to do 2 transactions. Let's say Ellis wants to allow the Ellis initial coin offering contract to sell 50% of all the Ellis coin tokens to buyers like Bob and Charlie. You can see here Ellis and Bob, and let's assume we also have Charlie out there somewhere. First, Ellis launches the Ellis coin ERC20 contract, which we have up here, Ellis coin, issuing all the Ellis coin to her own address. Then Ellis launches the Ellis ICO contract down here that can sell tokens in exchange for ETH. You know, if Bob wants to buy some Ellis coins, he's going to trade ETH to this Ellis ICO contract. Next, Ellis initiates the approve and transfer from workflow. She sends a transaction to the Ellis coin contract up here, calling approve with the address of the Ellis ICO contract and 50% of her total supply as arguments. This is going to trigger an approval event. Now the Ellis ICO contract is approved to sell Ellis coin to Bob and Charlie and other people. When the Ellis ICO contract receives ETH from Bob, it needs to send some Ellis coin to Bob in return. Within the Ellis ICO contract is an exchange rate between Ellis coin and ETH. The exchange rate that Ellis set when she created the Ellis ICO contract determines how many tokens Bob will receive for the amount of ETH Bob sent to the Ellis ICO contract. When the Ellis ICO contract calls the Ellis coin transferFrom function, it sets Ellis's address as a sender and Bob's address as a recipient, and uses the exchange rate to determine how many Ellis coin tokens are going to be transferred to Bob in the value field. The Ellis coin contract then transfers a balance from Ellis's address to Bob's address and triggers a transfer event. The Ellis ICO contract can call transferFrom an unlimited number of times as long as it doesn't exceed the approval limit that Ellis set. The Ellis ICO contract can keep track of how many Ellis coin tokens it can sell by calling the allowance function. Just a reminder, initial coin offerings are crowdfunding mechanisms used by companies and organizations to raise money by selling tokens. The terms derive from initial public offering or IPO, which is the process by which a public company offers shares for sales to investors on a stock exchange. Unlike the highly regulated IPO markets, ICOs are open, global, and messy. The examples and explanations of ICOs that I'm doing are not an endorsement of this type of fundraising. So while it's possible to implement an ERC20 compatible token in about 30 lines of code, Solidity code, most implementations are more complicated. This is to account for potential security vulnerabilities. There are 2 implementations mentioned in the ERC20 standard. There's consensus ERC20, a simple and easy to read implementation of an ERC20 compatible token. And there's the Open Zeppelin standard token, which, this implementation is ERC20 compatible and has some additional security precautions. It forms the basis of Open Zeppelin libraries, implementing more complicated ERC20 compatible tokens with fundraising caps, auctions, vesting schedules, and other features. So if you're thinking about creating and launching your own token, you probably want to use, an Ethereum development environment. For example, the Truffle framework is a development environment and testing framework based on the Ethereum virtual machine that you can use to set up an ERC20 token development project. I'm going to show you a sample, very simple token that we can create. We'll call it METoken.solidity, which will inherit its functionality from the Open Zeppelin library. Again, Open Zeppelin library implements some important security checks, and it's pretty easy to inherit from and extend. We'll also show some examples using Ganache, which is a great choice for a personal blockchain you want to run on your own personal computer to test out what you have developed before deploying it to Ethereum testnet or Ethereum mainnet. So here's a look at our simple ERC20 token. This one is going to inherit all the functionality from Open Zeppelin. It's got a couple decimals in here. It's got limited supply, 21 million, kind of similar to Bitcoin, and transaction workflows can then subsequently run on this. So basically, we're importing the Open Zeppelin Solidity contracts token, ERC20 Standard Token.solidity, and our token, the METoken, is inheriting from Standard Token. And we specify our name and our symbol and our decimals, our initial supply. And then in our constructor function, we then set up what those initial supply is, and then we send out an event about that, transferring our initial supply to the owner of the contract. So again, having a large number of tokens, as well as we can subdivide those tokens, gives us the ability to do a lot. And we're using Ganache to actually do, run our blockchain. So here, for example, we can see once we deploy our Solidity contract we just wrote, we can then deploy it, and we can see that we've created some transactions as part of our deployment on Ganache. So for example, we've got a contract call, then we have a contract creation, and we got another contract call and another contract creation. Then you can further interact with your contract on the Ganache blockchain, and run some of the functions, do transfers, and all sorts of things, interacting with it just as if it was in the production mainnet. So you can do pretty much everything you would want to do in Ganache that you can do on the full Ethereum blockchain, except of course here you're not spending real money, whereas if you were doing this on the full Ethereum blockchain, you would be spending real money. Instead, we can generate as much gas and ETH as we want to test out this contract before we go live. So here's an example of doing a transfer, showing that we're doing a transfer and sending ETH from one address to another. Again, we have this little transaction here, and we're seeing the details going from the sender address to the contract address, and talking about how many tokens we passed. So this is just showing you what it would be like to set up an ERC20 token and transfer some tokens from one account to another using the Ethereum blockchain on Ganache. So let's talk about some of the issues with ERC20 tokens. One of the issues is that If a user incorrectly attempts to transfer ERC20 tokens to a contract address that's not equipped to receive them, then the tokens are going to be lost. If you try and transfer ETH to a contract that's not expecting it, that ETH will still go to the contract, and you can eventually get it back from the contract, assuming there's a function that enables you to get it back. But if there's no contract there, then obviously the ETH is going to be lost. And if you send tokens to a contract that's not expecting them, which most contracts are not going to be expecting tokens, then those tokens are going to be lost. Some of the other issues with ERC20 tokens. Well, first off, the adoption of the ERC20 token standard has been really amazing. Literally thousands of tokens have been launched, both to experiment with new capabilities and to raise funds in various crowd-funded auctions and initial coin offerings. However, there are several potential pitfalls. In addition to the issue of transferring tokens to contract addresses, one of the less obvious issues with ERC20 tokens is that they expose subtle differences between tokens and Ether itself. Whereas Ether is transferred by a transaction that has a recipient address as its destination, token transfers occur within the specific token contract state and have the token contract as their destination, not the recipient's address. The token contract tracks balances and issues events. In a token transfer, no transaction is actually sent to the recipient of the token. Instead, the recipient's address is added to a map within the token contract itself, and their balance is changed. A transaction sending Ether to an address is actually changing the state of the address. A transaction transferring a token to an address only changes the state of the token contract, not the state of the recipient address. Even a wallet that has support for ERC20 tokens does not become aware of a token balance unless the user explicitly adds a specific token contract to watch. Some wallets watch the most popular token contracts to detect balances held by addresses they control, but that's limited to a small fraction of existing ERC20 contracts. In fact, it's unlikely that a user would want to track all balances and all possible ERC20 token contracts. Many ERC20 tokens are more like email spam than usable tokens. They automatically create balances for accounts that have Ether activity in order to attract users. If you have an Ethereum address with a long history of activity, especially if it was created in the pre-sale, you'll find it full of junk tokens that appeared out of nowhere. Of course, the address isn't really full of tokens. It's the token contracts that have your address in them. You only see these balances of these token contracts being watched by the Block Explorer wallet you use to view your address. Tokens don't behave the same way as Ether. Ether is sent with the send function and accepted by any payable function in the contract or any externally ownable address. Tokens are sent using transfer or approve and transferFrom functions that exist only in the ERC20 contract and do not, at least in ERC20, trigger any payable functions in a recipient contract. Tokens are meant to function just like a cryptocurrency such as Ether, but they come with certain differences that can make them difficult to handle at times. Consider another issue. To send Ether or use any Ethereum contract, you need Ether to pay for gas. To send tokens, you also need Ether. You cannot pay for a transaction's gas with a token, and the token contract can't pay for the gas for you. This may change at some point in the distant future, but in the meantime, this can cause some rather strange user experiences. For example, let's say you use an exchange or Shapeshift to convert some Bitcoin to a token. You receive the token in a wallet that tracks that token's contract and shows your balance. It looks the same as any of the other cryptocurrencies you have in your wallet. Try sending the token, though, and your wallet will inform you that you need Ether to do that. You might be confused. After all, you didn't need Ether to receive the token. Perhaps you have no Ether. Perhaps you didn't even know the token was an ERC20 token on Ethereum. Maybe you thought it was a cryptocurrency with its own blockchain. The illusion that tokens are just cryptocurrencies was just shattered for you. Some of these issues are specific to ERC20 tokens. Others are more general issues that relate to abstraction and interface boundaries within Ethereum. Some can be solved by changing the token interface, while others may need changes to fundamental structures within Ethereum, such as the distinction between externally owned addresses and contracts, and between transactions and messages. Some of these distinctions may not be solvable exactly and may require user interface design to hide the nuances and make the user experience consistent regardless of the underlying distinctions. So I'd like to thank everyone for watching this short little lecture on the ERC20 token standard. Tune in next time when I'm going to dive into taking a look at some of the other Ethereum token standards, including the standard for non-fungible tokens, ERC 721.